So my name is Jerry Lacey. I've taught at Mesa Community College for 25 years, SolidWorks, various CAM programs, started with TechSoft Pro Cam in the long time ago, mid-90s, transitioned into CamWorks, did Master Cam, did Solid Cam. So if I start switching between programs, you'll know what's going on. So, you know, done quite a few different models. And I just wanted to kind of elaborate and mention a couple of items here. So everybody's, make sure this is coming up. Everybody should be familiar with the bottom-up assembly. You build the parts, everything comes in, you control the mates. This was an example of if I brought in the toolbox items or somebody that had a basic version going out to McMaster to a Granger and downloading their model of a hex screw, bringing that in and being able to utilize it in their model. So everything that changes on this has to gone through one at a time. And with 3 parts, that's not really that big of a deal. You get up into more parts, then we have the resilience issues of tying this all together. So multi-body or master model is kind of SolidWorks, and you'll see, oh, I guess that's the drawing. I should have paid attention to what I was doing. So let's see, the drawing, let's just go into the assembly, and it should ask me for reference documents. So in this case, this being a multi-body, and I didn't pay attention to my own naming nomenclature there. So in this case, I end up with, I like to organize by folders. So each of the parts becomes a solid body related back to one point of failure. My little sketch there for the revolve profiles, the hole locations for each of the items. And if anything changes, I go back to one of those 2 sketches and build it. Now, my personal feeling is that up to about 15, 20 parts, multi-body modeling is gonna perform very well, but there's gonna come a point where you go, wow, this just became way too complicated. And that's where we're gonna make the jump over into top-down assembly. So with the solid bodies, there's this little thing called save bodies. And when you output that, depending on what you name those solid bodies, and I just covered it up, but depending on what you've named those bodies, you will get that as the naming convention going out to the individual parts, and then it creates your assembly, and all of that associativity ties back to those parts. Okay, on the top down components that I've done, I think of probably my prime example is I did 5,000 gallon, 1,200 to 5,000 gallon water tanks for construction equipment. And I started off with that multi-body, and very quickly I realized I was in way over my head. And at that point, I jumped into top-down assembly. So with a top-down assembly process, yeah, I jumped out of that. Hopefully this will find it. So again, my naming going from MB to TD or top-down. We end up with an assembly and more reference documents. So these become components, new parts in the assembly. And I did this lecture for my class Sunday or Monday, somewhere in there. And I forgot the very first rule of all top down: save the name immediately, because all of this associativity is tied back to that name. Assembly 1 if you don't save it. And then when you do save it, it says, oh, you don't want to do that. you want to keep the name that you have or use the file utilities after the fact to update. All right, so still with the hole locations. Find my mouse here. And again, with parent-child relations, if you're not using the dynamic arrows, these are good ways to relate back to the geometry. So in this case, I did the hole locations. I think I probably did the layout sketch. If you're comfortable with 3D sketches, you can do the a layout and have different views. Whenever I design boxes, acrylic boxes, enclosures, I do top down and I do 3D sketches, and I drive everything from that one sketch, a single point of failure. And so the layout sketch controls my 3 revolves. Each of these will have sketches in them that have no dimensions or only 1 or 2 dimension. So if I was to edit one of these in context, it would all be tied back to that assembly, or in the case of the master model, back to those basic sketches. All right, so the other thing that I mentioned, and again, I don't want, I still want to do CAM, but I can't resist. We mentioned the auto trace. So in the add-ins, when you do the little pull down arrow next to the options, the settings, auto trace is in the SolidWorks add-ins. And as with most of the, covering it up, there's the raster to vector conversion of sketch picture. As with most of these, unless you're using them, they're just taking up resources on your computer. They're using memory. They're something that is probably better suited for what you're working on rather than something that you're really not using. So just like with the assemblies, I don't turn the toolbox on until I'm ready to start adding hardware and put in the washers and the screws. So I've activated the SolidWorks Cam. So again, another segue into our cam. So this SolidWorks Cam is a 1 year. So if you're on subscription, this cam will be good until this expires. Even though my license is perpetual, if I decided not to renew, I would, still be able to use SolidWorks, but the cam would expire next July. Okay, and then if you have purchased the bundle, talk to your reseller on that one, because I'm not that familiar with. So like I mentioned, I use ProCam, TechSoft ProCam, 2D and 3D, transitioned into CamWorks, used CamWorks for 15, 16 years, transitioned to the SolidWorks Cam, I've used Mastercam, I've used just about everything. All right, so they all have advantages and disadvantages. As we move into the solid modelers though, this living inside of and having that instant associativity, I don't have to push it back out to a standalone. It's either going to recognize it, be happy, or it's going to recognize it and maybe be unhappy. So let's see if I can fly that. Okay, I'm used to WebEx where that kind of drops out. All right, so I would program this one, but it's kind of a little more complicated with within the geometry than my block with a hole in it. All right, so we have a half 13 inside of a 2x3. One of the things that I've always had, I want to say hesitation or in the presentations, in the tutorials that I've seen, is we don't do enough with sketches inside of the solid model. They push more towards just doing everything with this geometry. I'm a sketcher. I like drawing everything. So I've gotten into my design library and I've created, hopefully on this one, I don't see it now. Okay, since I don't see it now, that means I lost it. I did not prepare. I made a library feature for the stock, which is just a basic sketch that I can drag and drop and use to position and say, I know what size the stock is. I don't have to add any material to it. I don't have to go through those calculations to say, put a little bit here, a little bit there. Also with targets, if these were filleted edges, I couldn't just pick up, well, I could just pick up the origin, but in most cases, I couldn't just pick up an intersecting corner when my X and Y locations are going to be one of those 2 edges. And so once we've gotten into decided how we're going to manage the stock, how we're going to create this coordinate system inside our envelope, these are going to be one of those basic prismatic shapes, and prismatic shapes are cheap. And from a manufacturing standpoint, if I can cut you a nice rectangular piece and put a hole in it, that's going to cost you the least amount of money. Start adding all of those really cool, that's a nice piece of geometry. That's also probably an expensive piece of geometry. So we want to be aware of what those are, what the downstream effects are. So when we do the add-in, we're going to have 3 tabs. In this case, it's the SolidWorks Cam. Regardless of which software, always find out where your options are. And on SolidWorks, we went up the little gear. There are hundreds of little tidbits of information in there that are going to make it the way you want it, the way you like to work. So if something's annoying you, go do a little digging. They have a nice search utility now inside of the options. Oh, I can see it up there. It's not on my. Okay, now I just got to find my mouse again. Anyway, go into the options, do a search for whatever it is you think that it might be called. See what those options can go back to. So in the case of our cam, right click, and I am a heavy right clicker. I hardly go up to the tabs if I don't have to. So based on the videos that I make and the presentation size, I like to have the screen down around the 1600 by whatever it works out to. And having that those tabs collapse is great. So when you're going through and setting up your work area, the options in the CAM programs are going to tell you, again, information, things that are going on in the background. So even if you have no idea what any of these things do, give it the glance. And almost every CAM presentation starts this way: is find your options, just go through and give it a quick look. In this case, because we're going to be dealing with extracting machinable features, recognizing that that geometry, there's things that we would want it to look for, and things that we, it'd really be nice if it ignored this. So the process, I would say that CamWorks and CAM have a fairly steep learning curve initially. You're going to spend 2 to 3 months getting this to work the way you want. Once that plateaus, the return on investment is just like right there, because it's going to recognize that geometry. And you're going to have, say, 60 to 70% complete programs coming out of the extract machinable features, but you have to work up to it. So our other programs have a slower learning curve, but at the other side, there's maybe not as much horsepower. So at some point, you're going to meet at that same plateau point of it does what you want it to do. It generates good code. It makes good parts. All right, so we want it to recognize holes, non-holes, meaning pockets, bosses, geometry. Faces, I don't bother with as well. I don't like the way it does faces, so I just say I will do the facing operations. And the part perimeter sometimes. Excuse me. And let's see, we'll just kind of jump through these pretty quick. And then display things that we would want to see. What are the simulations are doing? Updating, because you can go back to the model and make changes. What happens when you jump back into the CAM module? And the CAM module says, oh, I see you made a change. What do you want to do? How do you want it to interact with that change? All right, sometimes it may lose that feature. It may completely say, I can't do that operation the way that it was selected, the way that it was generated. You have to start over on that one. So how do you want to manage those? And then file locations for the different items. And then do you want the G code when you post to open up into an editor? All right. We're gonna, I really wanna, at this point, I would go into the TechDB, because that monstrous database is the horsepower behind extract machinable features. It's very intimidating to look at all of those lines and all of that logic, and you just get in there and want to push buttons and see what that does and get those things going. At the very least, you should be able to set up a machine. So when I edit the definition of a machine, this is going into the TechDB, and it's saying can't find my post processor. So let's see, we need to set up the definition. Let's see, our configurations showing up on this one might be in the full version. I say full, the bundled version, where configurations can control the configurations of the model. You need configurations, go back to the last presentation I did, and it can also control the machines. We've had machines that 12,000, 10,000, 7,500, 4,000 RPM on the spindle. I would program to the highest machine. And then if I decided, hey, I'm going to go put this on the 4,000 RPM machine, when I changed that configuration, the software would see it, update those RPMs and feed rates based on what I told it to do and output the code. If I programmed at the lowest rate, well, I'd have to go through each one because it will come down, but it doesn't like to go back up. So we're telling it it's a mill-inch, 12,000 RPM spindle. If you want to get nitpicky and you're really trying to look for that last millisecond of machine time, then you're going to want to put in all of those ramps and the really cool, takes the spindle 10 milliseconds to spin up to 12,000 RPM, 15 milliseconds to spin down, and acceleration on your XY moves. You can build all that in. I've never been that concerned about it. I'm relying on that at the machine to see what it does. My initial goal is to get a program out, get parts running on the machine, and then I'll worry about fine tuning. If I'm making one, great, I'm done. Get the part made, go on. If I'm making 100, somewhere in that 100, I'm going to find places to refine it, find 5 or 10 minutes per part, depending on the cycle times, of course. And then, if we're making thousands or tens of thousands, or that machine is only ever going to run that part, I have a window to reduce and get more efficient on the tools, get more efficient on the operations, and through that iterative process, become better at the that particular part. So we have an empty tool crib, we have a default tool crib, and this is where we're going to set up for the tools. Now, most of the machines nowadays have side mount tool changers. So typically we load tools 10 through 17 as our 3/4 inch, 1/2 inch, 3/8 inch. We would go down to 1/8 of an inch, a chamfer tool, a center drill, and then an engraving tool. All right, so those just live in the machine. When we calibrate once a month, we go through and double check that those are still staying within the parameters. But I would create that list and say that is my tool crib. If I want to start off with our umbrella machine that really doesn't care if I load 7 tools in there and lead them, it doesn't help, it doesn't hurt, then I start off with tools 1 through 10 all the time. And then when I select that tool crib, now I can add tools at this stage, or I can add the tools as I go. And then, so let's just go ahead and add one. I want to put in a 1/2 inch end mill. So the tool type will be a flat end. There are a lot of them, so I don't want to search, but I can tell it, find me a 0.5. 1/2 inch 4 flute, 1/2 inch 2 flute. Might make an adjustment and find a nice zirconium coated 3 flute in there somewhere, and or make the adjustment for it. Okay, and that adds it to the list. It's in station number 1. And whatever was programmed into that, I can override or I can accept. And as I build this in, I'm going to start putting in the feeds and speeds that I like and want to run it. All right, so I don't have a post processor apparently. So I'm gonna have to dust off some brain cells and try to remember where that goes at. We may have to bypass the post processor until yeah, why don't we do that? Because I'm gonna be looking for that for a little while. Since it didn't jump right to my subfolder. I know it's buried down there in SolidWorks and it should find it, but I did not check this far on my preparation, so I apologize. And we go into the setup. Are we doing 4th axis? So when we start talking about axes, 2 axis, I have a knee mill with a motor on the X, a motor on the Y, and I'm standing there with the quill moving it up and down. Call that 2 axis. 2.5 axis is our programming, like this nice block with a hole in it, is going to be the tool is moving in X and Y to position, comes down in Z, does whatever engagement it needs, moves around, retracts back up. 3-axis, we're looking at something like the mouse. I need to move simultaneously on all 3 axes. 4th axis, rotate to position, do whatever 2.5 axis you need. 4th axis simultaneously, it's moving while the tool's doing all that, and each time we get a little more complex. 3 plus 2, and I forget my terminologies confused, but 3 plus 2 on the 5 axis says we're going to rotate to position 5 sides of the cube. We're going to be able to reach and do those 2.5 axis operations on more faces of that cube. 5 axis simultaneous, when they show you the whiz bang, really cool turbine blades, it's moving all over the place. That's the 5 axis simultaneous. So we need to set, if we need to set those up, we have those available as rotary and axis. All right, so other than my post-processor issue, I think we'll move on. So like I said, if I have a piece of oversized stock, I have to check, but also at this level with included cam, we're going to be able to do parts. If you want to do assemblies and be able to do multi-vices, multi-fixtures, multi-everything, then you're going to have to step up to be able to really control and have access to that assembly. But we can do quite a bit with our 2.5 axis block. So when I decide if I do the rectangular sketch and say the stock is a little bit oversized, or I have the fillets and I drop in a nice round, nice circle with some lines in it to act as a target, then I can put that coordinate system anywhere on the block that I like. All right, so more decisions. Do I want to deal with this as, well, first of all, we've told it that it's an aluminum alloy, our favorite material to cut. Next to Delray. The bounding box is going to size the stock, and then we have options for predefined. Mainly if I drew a solid body, or if this was a casting, I had a model of the casting, I could import that in, put it around. My personal favorite, the extruded sketch. And then if it's cylindrical, like my pressure cylinder, I could define it as a circle and deal with that geometry, holding it in a 3-jaw chuck. Do we have STLs that can come in, or an individual part file? Let's just stay with the standard. Do I want to add any stock? In theory, you should add stock to Z if you're recognizing the face, because it like always errors. Says, oh, there's no material up there for me to cut. I don't recognize it. I don't have anything to recognize. What is it you want me to cut? And I end up going in and modifying. I don't like, and again, everybody has their preferences. So I would just say, my preference is I don't want to mess with the stock. I'd rather draw that rectangle and say, I know what that stock is doing. If it changes for some reason, I change the sketch, I change the extrude, it does fine. We have the stock, and then I need a coordinate system. Coordinate system should default to the origin. If I want to put it on any of the other corners, we can pick. And hence, if I had the sketch out here with just the end of the rectangle, I could pick that as my coordinate system. We could pick the center of the hole, or if we go to the bounding box, since I don't have any oversized stock, I'm going to have each of these little nodes to pick from and put it on those. I'm hesitant to those because I've had parts that were odd shapes, and when it got turned over or went to the second operation, then all of a sudden everything shifted because it recognized the stocks correctly, but it shifted it just a little bit because we'd already machined that face, or it was already done. So it's one of those, it bears recognizing. And then the stock, if we created the stock size, right now the stock and the boundary are the same. So if I go back to the entity and I pick the origin, may not have to, but to be safe, I want to control this without any issues. So I'm going to shift these around until I know that my coordinate system is placed on that part exactly where I want it. No surprises. Well, very few surprises. All right, coordinate system. We've gone through our checklist. we're ready to extract some machinable features. So we'll come over here to the cam and extract machinable features. Keep our fingers crossed. It didn't find the hole even. Interesting. I almost want to do that again just to see it not find something. So I either missed something or it really wants me to go through the entire setup. When I did this in the practice this afternoon, it found the open pocket perimeter, it found the hole, it found some other stuff that I don't even know what it was looking at. So never fails. All right, so we have a mill part setup. Ideally, I would see that setup come up with those 2 or 3 features underneath it. Make sure I'm right in the right tab here. So our tabs are the to recognize the features. We're going to have those list of feature definitions. Second tab is going to be the operations. Last tab is referencing our tool crib. Set up the mill setup. All right, I clicked the mill setup. Got me all flustered now. We have the front of the part. This little arrow down here only plays the minor role of, that's the direction of my Z. So not so minor. This is a really important little red arrow. So if I want to pick the geometry, doesn't really matter because I already set my coordinate system over here. I really just need to make sure that that target and arrow are in the same direction as my Z. If they're facing opposite, my operations are going to be a little bit wonky. Okay, they're going to be a lot. So we got a mill part set up. I really wish the extract machinable features had done what it was supposed to, but we'll walk through this as a manual operation. So I need to tell it that I'm looking for a facing feature. As I mentioned, if I select the entities, we'll go to the outside. I want it to ignore the hole. If I pick the face, sees that hole, it's going to try to face around it. It's going to say, oh, that must be an island. You don't want to do that, do you? So pay attention to the selections and the in condition. Again, I told it by default, it is up to stock. One of these days I'll go into TechDB and find that operation and say, no, I really just want to make that a blind and give it 10,000s, right? X and Y don't bother me so much to have it generating weird numbers, but usually my Z's, I want to see those numbers flying across the screen exactly where I think they should be. Looking at my print going, oh, it's 1/4 inch deep. It says 250. Why is it 260? Oh yeah, I put the stock thing in there. All right, I don't want to think that through because I'm deciding in seconds if I need to hit that E-stop and get this machine shut down before it plows through the part. All right, so direction looks okay. If not, well, now I can't really tell. So how about we go to 100,000s, and now I can really tell that there is stock above. All right, at this point, it's not going to add it in, so it doesn't really matter, but it's more of my mental checklist. And then we said that there wasn't an island. I don't think there's anything else I need there. There's not an island, but if we wanted it to ignore that, or if there were bosses in the middle, we could tell it to ignore those. All right, so the face feature, I could go ahead and send this to an operation plan. But we can also just keep adding these features. So a 2.5 axis operation. We have the an open profile would be I just want to cut along one edge. Boss would be the whole thing, and the available sketches should be my one. Now, as far as controlling depths, I have option. I can pick this top face and then in the operation tell it to go down, or I can pick the bottom face and tell it in the operation to go up. Again, preference. There's what you see when you see it, what you're most comfortable with, what will let you error check the easiest. All right, so I'm going to clear that selection and we'll do the loop, and it finds the bottom. And when I tell it to go up to stock, it already knows the depth. I don't have to go back and do anything with that depth. Let's see, we have an in condition. So I have to tell it it's showing the stock going out into air. It doesn't like cutting air like that. So We're going to tell it to go back up to stock. It kind of encloses everything, and it should recognize the boss. And then hopefully we can do the whole geometry. And it's in the selected entities. We'll pick that guy. And the end condition, it is set to drill. We want to change it to thread based on no operation has been defined. So it's close in the whole wizard, but maybe it's off by just a little bit. Don't know. But I've already defined it as a thread. I'm going to double check that. So I tell it I want it to go up to stock, and it will at least find that geometry. And if I've included stock on the bottom, it will find that as well. Again, I don't think I need anything else there. We have three features. And when I tell it to generate the operation plan, now it's going to go out to that tech DB and say, okay, here's what you told me to do. I can relate it to these geometries. Here's what I come up with, the face. So I'm not surprised, considering I didn't quite. So it added a tool that is not in my library. So it's telling me you probably want to do something about that. So I already added tool 1. I like the 3-inch face mill, but yeah, I'm probably just gonna run with my standard 1/2 inch at some crazy number. Tool holders, yeah, I haven't run this one, but I'm not worried about interferences. On the 5-axis, I'll be a little more worried about interference. I'll look at the tool holders. I'll want to see where that is. I'll add in those fixtures and those vices to control that. So the holder, the tool crib location, the station numbers, and then the feeds and speeds. Do we want to be out of the library, the operation? I like the operation. Surface feet per minute with a 1/2 inch. Okay, let's go 800. The manufacturer says I could run up to 1,000. That's about 9,200, something like that, at 40 or 50 inches a minute. 6111, and the feed per tooth at 17. Now we'll back that down to like 3. 36 is okay. And then I have to decide on my lead-ins, on my approaches, the XY feed rates and the Z feed rates. Do I want to be at percentages, or do I want to be at hard-coded numbers? If I check these to be percentages, it's going to look at this number, and I want to be at 50%. So it comes down to the clearance plane, it comes down to the retract plane. It engages into the part at 18 inches a minute, roughly. And then it takes off at 36, does the face, and when it feeds off, it comes out at 18 inches a minute. All right, so there's a lot going on here in these two very simple, well, all right, all of these, as I like to say, these 3 easy steps. Oops, I got out of it before I created the geometry. All right, more corners, more variables that we can go through. Do we want it to automatic face, step overs, overruns on the edges, overruns on the ends, and multiple steps? How do you want to make those approaches? Lots and lots of choices. Top of stock, one of the things that I really got used to in CamWorks was there was a global rapid point, so we could set that for every part. I'm still looking for that in here, and one of these days I'll find it, and then I'll be happy again. But the top of stock or top of feature, depending on what we're doing, 1 inch, 100 thousandths, everybody's standard. Come down to 1 inch, do the approach to 100 thousandths. I can look at that and say, yeah, that looks pretty good, or wow, that's either really far away, or that really shouldn't be touching the part yet. Right, so, and then feed planes, if we're going subsurface, we don't want to do that right now. We're using the face feature. It recognizes the depth. I can do overrides. The lead-ins, again, these look kind of complicated, but it's either based on, are you hard coding numbers, or are you using percentages of your tool? So a 1/2 inch tool at 55%. Make sure I'm telling you right on that. The little percentages highlighted over here. So it's going to go what, 270 on the lead-in clearance. 270. So that's going to cut quite a bit of air, even at 18 and 36 inches a minute. So On my first article, yeah, I'm probably going to be okay with that. And we'll make sure that everything runs smooth and I don't break any tools. And then I'll get closer and have it make that little bit of a buzz as it engages into the part on the lead-in. Advanced, more fun things that we can do. Mention the spline deviation. So not really on the facing operations, but we ran into an ellipse for a helicopter part that faceted, and it freaked everything. And we don't like those facets. I'm like, oh boy, you know. And so we looked through and we found the arc fit, and we stayed within tolerance, but it converted all those little faceted segments of, you know, whatever 60 or 100 thousandths into arc segments, and then the deviation controls it for tolerance. Right, so that elliptical top half shape became relatively smooth as opposed to, wow, it looks like crap. So you know, we have those available to us. Let's see, and then the final on the optimize. Again, the feedback we need to preview. There's my toolpath. All those squiggly lines tell me something, and does not matter the software. Those squiggly lines are everything. You live and watch tools die by them. So once we've accepted it, we'll expand that out. That becomes a non-magenta, non-purple operation. Now it is something that I can post to when I find my post processor. All right, so I need to go back. And this time I will just, well, we can go to the top level and just say generate the operation plan since I did just the one. Let's see if it's not going to find it. Oh, that's right, it didn't. Okay, have to switch gears here a little bit. All right, so we're going to insert a contour. Make sure I'm selecting right here. We have the tool, the 1/2 inch, the operation, it's finding the defaults, and the feature should be the rectangular boss and not the face. And I'm out of sequence here. I did not leave any stock. That's probably why it didn't find it. All right, well, okay, a little strange, but not a deal killer yet. So the 1/2 inch tool still. Let's see, we get into, all right, so these are the operation level. Our feeds and speeds, again, at the library level. And for this, I'll run it up a little bit faster since if I go to that 1,000 surface feet per minute, we're at the 760, not real fond, even though it rounds. I'm not real fond of 3 decimal places there. We'll go with the 50 and the 50, and my OCD is showing, I just can't help myself. The contour and allowance, if we want to make these passes and then step in and make a finish pass, again, thousands of little decisions. How do I want this to run? We have sub settings that can control the roughing, corners, you know, controlling round tools don't cut square corners. So how do we want to reduce chatter and reduce those types of things going into it? If I turn the ramp on, I'm really fond of ramps. So if I tell it first cut amount and 50%, 50%, we should get a ramp that starts up here, makes 2.5 passes and a finish pass to clean it up, rather than a step and repeat. On the aluminum, I would probably blast through that holes outside and end up with a spring pass, right? Again, do I go this way or do I go this way? I like them, so. And the NC, retract planes, compensation. Are we going to include our G41, G42 for the finish? Yes. Lead-ins, again, we can go through and fine tune these to the nth degree. Advanced, optimize, I'll keep my fingers crossed. And that error did not like something there. So I think it comes back to, since I did not add anything to my stock, I'm not going to see it. So let's try this real quick. And I won't spend a lot of time on this if it won't cooperate. So let's go 50 thousandths on X and 50 thousandths on Y. Stretches it out. Says you have changed. Do you want to rebuild? Yes. Now, my doing that, I've taken a risk because I did not update my coordinate system. It's still on the part. So am I going to control that at the controller? Or am I going to manage that at the controller? Or am I going to go back and change it here? All right, one more time. Generate, and then back to those options. How do I want this to manage? Do you want it to update, or do I just want it to go back through and regenerate the whole shebang? Probably should have regenerated it. We'll see if it generates tool path this time. Striking out on that one. All right, I did not stay with my standard recipe, so I'm paying for it now. If we edit the definition on this this whole, and I'm just going to go ahead and jump to the next one. There should be. Let's see. No. All right. Under the parameters, we've told it that it's a thread. It's a tap cutting, and again, it did not find that. So it only does that when. You know, when there's people watching. So we'll tell it that it's a half 13. And when it goes to the tech, and we'll use this as the tech DB example, and then I will finish up with that. So generate the operation plan. It finds a center drill that is not in my tool grip. It finds the tap drill. It finds the tap. And if we told it to, it would find a countersink to break that top edge as well. Just depends on what we're telling it to do. All right, so the center drill, it will find that geometry. Let's just stay with the drill. And I hate to leave this this unfinished, but I do want to touch on the tech DB. Is it found the 422, which is our tap drill. And again, if we go to the library, if I fill in those parameters with the library, I can leave it, but I'm not that trusting, especially with a 400 drill at 8,000 RPM pass. All right, so we'll go 200 into the aluminum on surface feet, and that should return something that's a little bit more manageable, under 2,000 preferably. So feed rate at 5 thousandths, 9 inches a minute on the, okay. And then it's pecking, 100 thousandths peck, that's about 25%. And we have the input, the values. I was expecting to see a percent. Okay, percent of tool diameter. And then percent of, so since the last time I used this regularly, that's been added, and interesting. So I'd probably try to go 150, 170 on that. Get a sense of how it's cutting, what it's doing, and then we'll worry about it. So add the tip length. And then, so calculated at 87, so it's going to go the ½ inch, we'll end up at 587. Top feature. And let's go ahead and preview it. Yeah, I got a hole that time. Maybe I didn't preview it. I jumped too soon on the contract. I'm going to try that real quick just because. Or I'm going to try and crash the computer one. Preview. No, it's just not going to let me have it. All right, so I would have to go back and diagnose that. We'll do the tap real quick. So it found in our database the ½ inch major diameter flute length. We would need to adjust those if we were trying to get this to go all the way through a tooling plate or whatever. 350, that's actually not too bad. I prefer numbers that are in increments of 13. So I end up with 10, 20, 30 inches per minute, or yeah, on the feed rate. So if I was to go 260, that would give me 20 inches per minute on the feed. It's a quick calculation, and it's a definite double check. Let's see, tap hole parameters. Do we dwell at the bottom? Reverse tapping, no. Again, don't really want it to go, well, it's half-inch part. Yeah, we do want it to go through. I'm still having flashbacks of the going through 2 or 3 times through the 2-inch plate. So tip length, no, we just want it to stop, or we want it to go through to the machining depth. Yeah, there shouldn't be a tip length. And machining depth, I can override it by saying, let's go, let's see, 2 to 3 to 4 threads lead, 87. We'd need to go about 250 to make sure that we have an almost complete thread at the very bottom because of the taper, depending on the style of tap. Again, all of these little parameters that become back to that. You're observing the tools, you're dealing with them. There is a lot of background information that just goes way beyond set up the machine, push the button, watch it go. So if I don't give you anything else, tonight we'll you get a sense of kind of the levels of complexity. Some of this, we make it way more complex than it needs, but that builds in safety. I know what it's going to do, how it's going to do it. I'm a lot less worried about it throwing the part out. And we don't like parts bouncing around the inside of machines. All right, so on the simulation side, what we have to simulate, we can simulate the toolpath, and we'll slow it down just a little bit because that'll fly by in nothing. And different programs manage simulations different ways. All right, you can have it run directly out of, have it launch a external. The main thing is I'm not looking for the part geometry here. I'm really looking that it didn't decide to take off and blast through my part somewhere and make a really, wow, I should not have told it to go that way. All right, because it's just a machine. It's going to do exactly what I tell it to, or hopefully what I want it to, or something like that. All right, we'll finish up with the tolerance-based machining. Came in right as I kind of transitioned out. So there is another level of complexity there that comes with what would we just say, statistical variation in what you can manage for the sizes, the size of the parts, how much tolerance builds into them. The TechDB, it is as monumental as it looks, but we can set up machines. We can look at the features and operations. Each of those items that worked or didn't work, as the case may be, relates back to a record number or record ID, and that stores the information of what we're telling it to do and the list, center drill, and drill. All right, if I need to add something or need to take it away, we would come in here and fine tune it. The preferred method would probably just be to, hey, I really like the way that operation worked. Let's transition it into the TechDB and let it overwrite, and I'll just make notes of where it went. Let's see, on the operation parameters. So if I wanted to look at that contour mill, let's try and see if it did something. It's machining with a bottom finish, standard speeds and feeds, and every one of those elements that we click through on those tabs is available to modify. And so like the thread milling, default setup parameters. I mean, there's just a lot of information in there. So even if you're not changing anything, it would be one of those, open it up and take a look and just kind of get familiar with it so that you can understand the connection between what's being generated here and what is happening. So where did it go to? I'm looking right at it. So somewhere in here, there is a right to TechDB, something like that. And I'm, again, dusting off brain cells on this one. But as I go through and I make these operations and I decide, hey, that was a really good operation, the way that it ran, I'm going to find that, write this to the database and have it take all the parameters of that operation and put it into the TechDB. Next time I see it, I should see all of those parameters. I do that enough times through enough iterations. Cool, I'm getting programs coming out of the back end of this thing that are nearly complete. All right, so not everything worked quite the way I expected to, wanted it to, but I got to show you all the high points. Do you have any questions? Sufficiently confused and overwhelmed? That's
It's been a little while since I've been through this interface as well, but the TechDB, do you know, is it a library that you can export and then pull into other workstations? Is there a feature that you can do that?
So
that you can kind of take your,
right.
you know.
And so this is at its very root on the CamWorks side. This is an access database.
Okay.
So in our, and again, we're having to stretch here a little bit to look at it or look for it. Let me just, the short answer is I would go find the export utility, output it to that file. Any major changes that I made, I would want to save that. Here's my pristine, unbuggered up version. And then I can proceed to do whatever I want with it and go have one to go back to, or, after doing this for, 10, 12 years, my TechDB was awesome. And, it'd be like whenever we uploaded the new version before the latest go, export it out, make sure we had that. This is the copy I like, just kind of like our post, because the post in the Cam and CamWorks are C++ based, so they have to be compiled. Other programs are using the Java and pretty much compile after the fact. We have to compile and then go through it. So a little more complicated. To that end, spend the money on the post with your reseller and get them to do exactly what you want. If there's something going on in that that outputted G&M code, I'd really like it to do this. Unless you're a programmer, then you probably just want to let somebody that knows do it. You do what you do best, getting the parts out the door.